Okay. Good everyone. My name is Engineer Dr. Ekene Samuel Ngon. I'm the Chief Technical Consultant for Smart What I Say Limited. We started the program on capacity building on outcome-based embedded system and product development last week now. So this week, of course, we have covered a number of grants. We have covered a number of grants. By now, you should be familiar with, every one of us should be familiar with Arduino programming, and you should have mastered the automatic street light. Remember, this program is outcome-based, so there are certain things expected of us at the end of the program. We're actually building up. We are building up. Today, this week, we shall be looking at, starting from Monday, we shall be looking at interfacing LCD to Arduino Uno using I2C model. So let me run through the lecture so that you can begin to prepare for tomorrow's class. So quickly, I will share my screen. Okay, so we are looking at interfacing alphanumeric LCD to Arduino Uno using integrated circuit model. That's I2C model. I've already said my name. Now, what is LCD? When we're talking about alphanumeric LCD, we're talking about LCD that can display alphabets, numbers, and then some special characters like hash, question mark, percentage. And talking about this LCD, they are in categories. You have 16 by 2, or you can also say 2 by 16, 2 by 16. If in metrics, when we talk about metrics in engineering, we take the rows first. So this is 2 by 16. 2 means 2 rows, 16 means 16 columns. For example, this one, if you count this, you will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this LCD can display a total of 16 characters in a row and a total of 32 characters in all. For 16, or rather 4 by 20, 4 by 20 means 4 rows, 1, 2, 3, 4, 20 characters. Let's count and see whether this is correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is 4 by 20 LCD. And this last one is 4 by 16. Well, what determines the one you choose is you. It depends on what you are working with. Of course, there are different other types of LCD. It is beyond the scope of this training. Let's get to the next slide. The next thing is pinout. Pinout of the LCD. They have told us that for you to do well in this domain, in this embedded system, electronics design, you get to learn how to interpret data sheets. It's a very key component when it comes to electronic design. So look at the pinout. That LCD, whether 16 by 2, 16, I mean, whether it's 2 by 16, whether it's 4 by 16, whether it's 4 by 20, they all have the same pinouts. Pin 1 VSS is always a ground, followed by VCC, which is 5 volts. You have the contrast, the control, which you use to change the background. I mean, how visible your character is. And then you have register set. This LCD came with an internal controller, so that interfaces we can write to and read from. To write to it or read from it, these 3 pins, RS, RW, EN, must be addressed in a certain order. We are not going to go into that order now because we are not going to write to them directly in this program. We are going to use an adapter. Our technology is advancing. We are seeing easier ways of doing things. I remember several years ago in 2005, 2006, when I was introduced to this LCD. All the advancements in technologies are not there. So when we were writing to this LCD using 89C51, you have to wire everything by yourself, understand the assembly language coding, write to these things from the assembly language, machine code, and get it to work. But nowadays, things have actually improved. So there is no point in reinventing the wheel. But it's good to make mention that you just to let you know that you can write to this LCD, you can also read from it. And then enable pin is there to enable. When you want to write or read, you simply have to toggle the pin. Then you have the data pins, which is pin D0 to D7, that is 8 lines. That is where you can supply, those are the input pins, and output pins you can use to supply data to the LCD or get out data from LCD. Incidentally, I2C is an adapter, so you don't really need to worry about all these things. The benefit of I2C is that it reduces all these, how many lines? Look at, if you're going to work with this the way it is, 8 plus 3, 8 plus 1, 2, 3, that is 11 lines. But I2C has reduced it to just, these 11 lines has reduced them to just 2 lines. That's a big benefit. And then you have internal LED, light emitting diode, call it backlight, so that you can see the LED, what is written on the LCD. The positive of that internal backlight is pin 15. It's always pin 15. And except if there's a factory fault in the production of the LCD, it's always pin 15. And then the LED, the pin 16 is in negative or the cathode of the LED. What it means is that you always need to connect a resistor. Either you power this LED from pin 16 to a resistor, or you ground it to a resistor, or usually 100 ohm resistor we do. 100 ohm resistor we do. That's that. Now this is the I2C module adapter for LCD. You can see it just has 4 lines. The first two are for power, VCC and ground. You simply connect this one to the VCC, 5 volts on your Arduino board, and then connect this one to the ground. SDA, that is the serial data line. I will let you know where to connect it. And then SCL, the serial clock, I will let you know where to connect it. It makes life very simple. And then this is your variable resistor that you use to vary the contrast. This pin here is for your backlight. If you remove this pin, the backlight will go off. Okay, I expect us to try this thing out. You try it out. Remember, this is hands-on. This is outcome-based. If you read it or you listen to this lecture, but you never practicalize this thing, you have not known it. You can only say that you have learned this thing when you have handled it, when you have handled it with your hand. That is the only time this thing will stick in you or with you. Now, you get to solder the adapter to your you get to solder it on your, together with your LCD. Have to mount it on the LCD. You have to do that very carefully. I recommend when we meet tomorrow, during the workshop, when we meet at the workshop, you are going to do this by yourself. I recommend you solder from left to right, just to make sure that you don't breach these lines, you don't breach them. So you have to solder at the workshop. The soldering lead will be made available, so the iron will be made available. You get to lay your hands on this and do it by yourself. Possibly we will divide you into 2 teams or 3 teams. But then you will notice that I2C, I2C didn't come, is not part of your Arduino board. Arduino key, so you get to buy it. Okay, it will be made available tomorrow. You can still pick it up. Now, after the soldering, you have to test that what you soldered is correct. First of all, you get to use a multimeter and check the continuity of these lines to be sure none of them is touching before you power your LCD. Please, you get to check the continuity properly before you power your LCD so that you don't end up destroying your LCD. After that, I've taken the continuity. You can now connect the power pins of the I2C. Once you power it up for the first time, you are going to get something like this. The LCD will just light up, but then won't be able to, the lines will not be visible. You get to use a small screwdriver and turn the potentiometer here. The voltage divider, the variable resistor here. Turn it. As you turn it, move it clockwise or anti-clockwise. You watch your LCD. Once these lines are visible on the first row, this space for characters are visible on the first row, then you are good to go. It means that your LCD is in order. That's that. So we'll move on. This is your connection, the wiring diagram now. Very simple. It's a straightforward something. You connect SCL on the I2C to A5 analog 5 analog A5 of your Arduino. That is analog channel 5. It must be there. It must be connected to this pin. You don't connect it to another pin because internally the SCL of Arduino Uno is connected to A5. And then similarly, you connect SDL to A4. Okay, and then that's it. Once you are done with that, that's that. You can see the one I did. You just do it. It's very simple to do. And then you will need to know the address. You need to find out the address of this I2C. What you do is you go to examples, go to wire, and then I2C scanner. You run the code. Just open the sketch, run it. When you run, after running it, you open your serial monitor, and then wait just a few seconds. The address of your address of the device, I2C device will pop up. And for this particular one we are using, the address is 0x27, 0x27. That is a decimal address. Okay, you need to take note of that because you're going to make use of it in your code. And we're getting close to the end of the discussion. You get to install Liquid Crystal I2C by Frank. by Frank de Brabanda. There are several libraries you will see concerning this, but the most reliable one is one created by Frank. So you go to a library manager, install it as discussed in the class. We've discussed how to install library last week, and we've done it practically. So I believe you should be able to follow the lecture. Now, once you are done, once you have installed the driver will come with an example program. So you go to Liquid Crystal I2C and then open Hello World as an example. You get to edit it. The Hello World is written for LCD 4x20 LCD. So that is not the one we're working with. We're working by 2x16. You get to edit it. And of course, coming to LCD addresses, this is when it comes to row, this is 0, this is row 0, column 0, row 0, column 1, row 0, column 3. You get to take note of that because you are going to make use of it to edit your sample code. For example, this program is asking this LCD to start at row 0, column 3, row 0, column 3, row 1, column 2. We'll take note of that. Here, you can see that that program has been modified to suit our design. So we're now dealing with 2x16 LCD, and we want to start the writing from row 0, column 3. Then that is Smart World will start at row 0, S will start at column 3, followed by M, column 4. But for the second line, we're starting, the second line, which is 1 now, because 0 and 1, counting start from 0 in digital system. RC will start from column 4. That's that. You make these changes and then upload your code to Arduino. If everything is the way it should be, you will see the result as shown on the screen, Smart World RC Limited. So that is the end of the presentation. Before we go, remember that this presentation is brought to you courtesy of Smart World RC Limited. Smart World RC Limited has electronic components for sale. You can join our WhatsApp group so that you'll be updated on various things we sell. LCD, Arduino kits, sensors, actuators, all kinds of things that students can use to implement their project. As a matter of fact, we also help students we train students. We don't do projects for them. We train them to do their projects. By God's grace, we have a number of final year students who are handling their projects. We don't want to throw the conventional thing, what is before now, students come do projects for them. No. We give them appropriate training and we encourage them and guide them to do their projects by themselves. And it has been fantastic what these children can actually do. They are doing marvelously well. They implement their final year projects by themselves, write the code by themselves. I just discovered that what these students need is actually a little support, just a little guide they will pick up. And then we also organize this training for schools, ongoing, as you may have known, biomedical engineering students are having their training where they are year 100 and 200 and 300 level. The training is ongoing now. hopefully by God's grace we can also conclude this week. So your school or your department can be the next in line. Contact us for all kinds of things, sensors. For example, this is what do you call it? This environmental sensor, this MP sensor, gas sensor, you can use it to monitor. I mean, this one, you can use it to monitor your environment. All these are variable. And these are our IT students. We take IT students, we train them, we coach them, and they are doing very well. These are the resistors for cells, and these are the kits for cells. We sell at interesting thing that will make it available within the campus and still sell at a very good price. So we expect to hear from you when we get to the class. You can ask your question, or you can still drop your question at YouTube channel. If you are not subscribed to our channel, subscribe to our channel. God bless you.